In this video, I'll be discussing a geometry problem involving circles. Refer to the figure below. AB equals to 2A. Construct semicircle O with diameter of AB. Take a moving point C on the upper half of the circle. Construct circle C that is tangent to AB at D. Circle C covers a part of triangle ABC. If we denote the rest of the area as S, which is the shaded area, find the maximum value of S. So, for this problem, I will first construct a very useful helping line. Since we want to find the area, we first need to know the area of a triangle. And if you use AB as the base, then the height would be CD. Okay, now you have to say connect CD. And let CD equals to H. Now, since circle C is tangent to AB at D, so CO and CD is going to be perpendicular to AB, because in circles, if we connect the center to the tangent point, this radius will be perpendicular to the tangent line. So which is basically CD is going to be perpendicular to AB. Now, let the area equal to S. Actually, we already know that the area equals to S, so S, we can represent it as the area of triangle ABC minus the area of a sector, which is going to be this part. This sector will be 1/4 of the entire area of circle C. Okay, since AB is going to be the diameter, so we can get that angle ACB equals to 90 degrees by the inscribed angle theorem, which means that angle ACB will be 1/2 the size of its central angle, in this case, which is angle AOB, which is going to be 180 degrees. So angle ACB equals to 90 degrees. This is very useful in geometry because if you have two chords whose endpoints are on opposite sides of the circle, and then AB is the diameter, we can get that angle ACB equals to 90 degrees. So A sector equals to 90/360 times A circle C. Know that this will equal to 1/4. So S equals to triangle ABC's area, which equals to AB, which is 2A, times H times 1/2, minus, well, we know that CD equals to H, so the area of circle C is going to be H squared pi. H squared pi over 4. Simplify to get this equal to AH minus pi over 4 H squared. And now, here's what makes this problem challenging. We will be using an algebra method called completing the square. completing the square, basically we want to get this in a perfect square form. Though there might be some leftovers. I'll tell you what I mean. So first of all, to complete the square, we have to factor out pi over 4 first. Because that is the coefficient of the quadratic term, which is h squared. And this will be negative pi over 4 because we want positive h squared. And in this case, we had negative pi over 4 h squared. So h squared minus, and now we don't want to change the value of this expression. So this is going to be 4ah over pi. We basically timed ah by negative 4 over pi. So if you do the distributive property, so negative pi over 4 times negative 4 over pi equals to 1. So a negative and negative sign cancel out. So it'll be positive ah if you expand the parentheses. And now we have an h squared here. And then negative 4ah divided by pi. This here can be simplified into perfect square form. It will be h minus 2a over pi squared. Why? Well, look, negative 4ah over pi, this will be the 2ab form. So here I can say that a plus b squared equals to a squared plus 2ab plus b squared. And a minus b squared to a squared minus 2ab plus b squared. Well, you see, this 4ah over pi will correspond to this negative 2ab. A squared will correspond to a squared. So, if you do it on the side, we can get that 4ah over pi. So 2ab. First of all, we have to divide this thing by 2. Divided by 2 equals to 2ah over pi. But then 2ah over pi will equal to ab. So we have to divide it by a. In this case, a equals to h. So 2ah over pi times 1 over h, which is the same thing as dividing by h. So this will be 2a over pi. So then this can be factored into a minus h minus 2a over pi parentheses squared. However, this is not equal to ah minus pi over 4 times h squared. Because you'll then have to add a squared over pi. Because in this form, we added a negative 2a over pi. So then 4a squared over pi equals to 2a over pi squared. But then, since we have this negative pi over 4, we have to multiply that. So negative pi over 4 times 4a squared over pi. And then you get negative, actually no, this will be pi squared. So negative a squared, positive a squared over pi. Because negative and negative cancel out. So these two negative signs will cancel out each other. And then that is how we got the a squared over pi squared. So now, how do you find a maximum? Well, this part's pretty obvious. When h equals to 2a over pi, S max is reached. If you still wondering why, well, you know that for perfect squares, they have to be positive. So, the minimum for a perfect square will be 0. So, when h equals to 2a over pi, h minus 2a over pi equals to 0. So, S max will equal to a squared over pi squared. No, a squared over pi. Okay. I made a little typo here. It's going to be a squared over pi. Then for this part, it's going to be 4a squared over pi squared, because negative 2a over pi squared equals to 4a squared over pi squared. So that is how you solve this problem. Well, the key concept here. Well, the helping line here is going to be pretty obvious because we want to find the area of this triangle. So CD will be the height. Now, you have to know that what a tangent line is. A tangent line, well, if you connect C and D, that's going to be the radius of circle C. Since AB is going to be tangent to circle C at D, then CD is going to be perpendicular to AB by tangent line properties. And also, another important part of this is going to be completing the square. Completing the square. So, key concepts. Completing the square. Completing the square is a very useful method when you want to find the minimum or the maximum of something. Because after in the square form, the leftover part, which in this case is a squared over pi, will gonna be the maximum part. Because you know that this is gonna be a negative. So if h minus 2a over pi, which is gonna be positive, if this thing is larger than 0, then after times by a negative number, it's going to be negative. So that's not going to be the maximum. So the maximum is going to reach when this thing equals to 0. And that is how we found out that the answer is going to be a squared over pi. Thank you for watching.